Hi, I'd like to welcome everyone to Algebra 1. This is Unit 1, Expressions and Equations. Make sure you have a notebook and a pencil handy so that you can take some notes while we go over this lesson. The objective today is so that the students will be able to write an algebraic expression. You'll also be able to look at an algebraic expression and talk about it in words. Algebraic expressions are mathematical phrases. They contain one or more variables. A variable can be any kind of symbol, we usually use letters, that represent values of varying quantities. Now, we tend to use x, y, z, but really any letter can work as a variable. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. So an example of a numerical expression would be something like 3 plus 7. An example of an algebraic expression would be 4 plus x. Now, notice in neither of those examples I didn't say equals in either of them. That's why they're expressions, not equations. So that's going to be an important thing to keep in mind that we're going to be dealing with right now are just expressions. So we can write expressions with addition and subtraction. So when we look at writing expressions, one of the things we want to look at is what kind of operation might be being used. For example, here, this word phrase says 32 more than a number n. So I have some number n, I have no idea how much that is, just some amount. And I have 32 more than that. So now I have all of n and all of 32 here. So in other words, I have n plus 32. Over here, I have 58 less than a number n. So here's my number n now. I don't know how much. And I have 58 more, or I'm sorry, 58 less. So as I put this over here, n has gotten smaller. Well, there's 58 less than n, so it's gotten smaller. So when we see the word less here, we must be thinking of subtraction. So if I take all of n and I subtract 58, that would be this expression. N minus 58. So more than is going to be addition. Less than is going to be subtraction. Another way we can write expressions is with multiplication and division. So looking at this word phrase here, it says 8 times a number n. Well, most of us know that times is going to mean multiply. So what I'm looking for here is how many times I have n. Well, I have n 8 times. In other words, when we write multiplication with a variable and a what's called coefficient, which is the number 8 here in front, we just write them together. So 8n. And that means 8 times n. We can also do quotients. We can write word phrases with quotients. So the quotient of a number n and 5. So basically what this means is I'm going to take some number n, this whole amount, and I'm going to divide it into 5 equal portions. In other words, I take n, and I divide it by 5. We could also see this as n divided by 5 as a fraction. I have 5 parts of n. Alright, now that we've done expressions with addition, subtraction, multiplication, and division, we can now start doing multiple step expressions that are involving more than one operation at a time. For example, we have a sentence here that says 3 more than twice a number x. So, a couple different ways you can do this. The way I like to look at it is I always like to start with whatever's happening to the variable first. So it says 3 more than twice a number x. Well, this twice a number x is what's happening first. That means I'm taking x and doubling it. In other words, I'm taking x and multiplying it by 2. So I'm going to write that here first. 2 times x. And remember, we can just write the 2 right next to the x, and that means 2 times x. But now I have this other part, this 3 more than. Well, remember earlier we said whenever we see more than, we're going to be doing addition. So I have 3 plus twice a number x. So I have over here 3 plus twice a number x. Let's try this one. 9 less than the quotient of 6 and a number x. Well, again, I like to start with whatever's happening to the variable first. So I need to look at these words here, and I see quotient. That's going to tell me I'm dividing. So the quotient of 6 and a number x. Okay, so that means I'm going to take 6 and be dividing it by x. Now this says 9 less than the quotient of this. This is where it gets a little tricky. If I already have this and I want 9 less than that, then that means I have to subtract 9 from this. So let me move this over here. Here's my quotient. And now I have to do 9 less, so minus 9. This tells me I have 9 less than the quotient of 6 and a number x. This last one here, the product of 4 and the sum of a number x and 7. So first thing I like to do again is I like to find out what's happening directly to my variable. And here it is, the sum of a number x and 7. The word sum means addition. So I'm going to take and add x plus 7 because it's the sum of x and 7. So I have this x plus 7. Now I have to figure out the rest of this. The product means multiply. The product of 4 and this whole thing, the sum of x and 7. So it's this whole thing. We need to use parentheses to show it's this whole piece. And it's the product of 4 and all of that. So 4 times all of this. And again, I can just put the 4 next to the parentheses, and this is going to indicate multiplication. So this says the product of 4 and the sum of x and a number 7. Alright, just like I said earlier, we can also take and use words to talk about a mathematical expression, either algebraic or numeric. So we're kind of going to go backwards now from what we were just doing. So what word phrase can you use to represent the algebraic expression 3x? And again, when you write a number next to a variable like this, it means multiplication. So here's the expression 3 times x. And a variable and a number side by side indicating multiplication. So this simply means 3 times some number x, or the product of 3 and a number x. The product, again, product means multiply. Product of 3 and some number x. Alright, so here's where we're going with all of this. Suppose you wanted to draw a line segment from any one vertex of a regular polygon to the other vertices. Now, a vertex are these corners, okay? The vertices are the corners. The question here is, what is a rule for the number of non-overlapping triangles that are formed? And then we want to give that rule in words and as an algebraic expression. So that basically what we're looking for is so we could come up with a rule for any single polygon that's out there, any regular polygon, and be able to determine how many triangles make up that polygon. So over here, if we want to take a look, we can see that this is a regular hexagon, six-sided geometric figure. Every side's the same length. So when we're talking about how many non-overlapping triangles, it says drawing a line from any vertex of a regular polygon to the other vertices. Well, here's one vertex. If I were to draw a line from there to here, this vertex here, that would be along the edge. So that's not going to do anything for me. But if I started here and drew a line up to that vertex, now that creates one triangle. Now, starting at the same starting spot, let's draw lines to the other vertices. So here's one, and here's one. And if I drew one to here, again, it would just still make, it would be along the outer edge here, and I wouldn't be making another triangle. So let's see. So I have 1, 2, 3, 4 triangles when I do this. So how many non-overlapping triangles were formed? The answer is 4. Alright, so look down here. Triangles in polygons. Well, that's what this is. This was a polygon, multiple-sided figure. And how many triangles were 4? So when I have a number of sides of a polygon, when it was 6, so my hexagon, the number of triangles was 6 minus 2, which is 4. Okay, well, let's see. So if a polygon had 4 sides, so like a square or a rectangle, here's a nice square right here. So if I take this square and I start at one vertex, going from here to here, again, that's not going to do anything. But from here to here, that's going to create 2 triangles. So when I have a 4-sided polygon, I can create 2 triangles. So 4 minus 2, that's going to give me my 2 triangles. So what do we think is going to happen here? If we had a 5-sided shape, a pentagon, and we made triangles from the vertices, we're going to end up with 3 triangles. In other words, 5 minus 2. So what's happening here is we're taking the amount of sides of the polygon every time and we're subtracting 2, and that's going to become the number of triangles that that shape has. So if my polygon has n sides, in other words, I don't know how many, just has a bunch of sides, how could I write the number of triangles? Well, it would be all the sides of the polygon minus 2. N minus 2. So let's take a look and see how we could write that in words. We would have 2 less than the number of sides of a regular polygon. Let's see if that makes sense. Here's the number of sides of a regular polygon, n, and I have 2 less than that. So 2 less than the number of sides of a regular polygon. Remember, it wouldn't make sense to do 2 minus n. Okay, the polygon has more sides than there are triangles that are going to be formed. And n minus 2 is the algebraic expression that we would use for this. Alright, so here's the check your understanding. We're done with this lesson, so what I'd like you to do is to take a minute and answer A, B, C, D, and E on a separate sheet of paper in your notes, something that you'll be able to tear out or hand in tomorrow, so that I know that you were able to watch this video and really understand the main points of what's going on in the video. Feel free also to take this time to write down any questions you might have for me for something that might not have been explained very well, or you just want some extra clarification on, and that we can talk about in the beginning of class tomorrow. All right, we'll see you then.